Okay, we're doing worksheet for 3A in the Math 4 course, and I somehow found this humorous. You know, it's one thing to just call it a log, but you know, when you start calling it a logarithm, it's like you just put on a fancy coat and tie or something like that. And of course, Winnie the Pooh in that, just the whole look on his face. Nope, I would never see that. Anyway. Now, you are supposed to simplify this so that your answer contains only positive exponents. So, for starters, we can look at the 4 over the 4 and say, yep, they cancel. So I'm just left with 1. Now, if I have an x to the 0, that's 1 also. Now, I could say 0 minus 1. Matter of fact, I think I will do that. I will go ahead and do the normal subtraction we would do here. 0 minus 1 gives me x to the negative 1. Then I've got the y to the negative 2. Then I've got the z to the 3. Now, this is where I take my negatives and I start putting them underneath. And I got x and I got y squared. And that's what your first one is going to look like. You don't really need ones there because the 4s cancel out and you've already got players on both the top and the bottom. So you don't need a placeholder 1. All right, next guy. The 2 and the 3 aren't going anywhere. They're not canceling. So I'm going to start it like that. The h has nothing to cancel with. J negative 3 minus 1 is going to give me j to the negative 4. K to the 4 minus 1 is going to leave me with k to the 3. So I'm going to wind up with a 2 on top and an h cubed and a k cubed. And I'm going to wind up with a 3 on the bottom with a j to the 4th. That's what that answer is going to look like. All right, for this one, the 4 and the 3 aren't going anywhere. I'm going to leave it like that. M to the 4 minus 2, N to the 3 minus 2, P to the 3 minus 4. So I'm going to have on top, I'm going to have a 4m squared n on top. Now I have a 3 and a p to the 1 on the bottom. So I might as well just leave it at 3p. Okay, here my 3 on the top is not going anywhere. X to the 3 minus negative 4. Minus negative 4, that's like 3 plus 4. That's x to the 7. Y to the negative 1 minus 0 is still going to be y to the negative 1. Z to the negative 1 minus 0 is still going to be z to the negative 1. Now I've got 3 and I've got x to the 7 on top, but I've got a y and a z on the bottom. Now, we are solving these. We have to remember that when there's that multiplication in the middle like that I am going to add the exponents. 3m plus negative m equals negative 2m. All right, so if I say 3m plus negative 2m, that's 2m equals negative 2m. Well, this is going to get interesting real fast, because as soon as I add 2m to both sides, 4m equals 0, which means that m equals 0. And you know, if I put a 0 up there, I get 6 to the 0 times 6 to the 0 equals 6 to the 0. 1 times 1 equals 1. Yeah, that works. Now for this guy, I'm hoping that you'll realize that 9 and 27 and 81 are all multiples of 3. So we're going to need to, first of all, rewrite this as 3 to the 4th times 3 squared raised to the negative 2b minus 2. And this is 3 to the 3rd. Now, if I'm going to, I've got a base 3 here, but what I'm looking at is 4 plus 2 times negative 2b minus 2 equals 3. 4 plus, I guess I need to say minus, that's going to turn out negative, minus 4b minus 4. Which 4 minus 4 is going to cancel out. I'm going to be left with that. Divided by negative 4. And so if I stick negative 3/4 up in there, I get negative 1.5. That's not going to be pretty. But anyway, it works. That just would take me a while to walk through the steps of plugging it in. All right, so now we get to play a similar game here. I'm going to rewrite 16 as 2 to the 4th raised to the 2p minus 3. 2 squared raised to the negative 2p equals 2 to the 4th. So I'm going to have 4 times 2p minus 3 plus 2 times negative 2p equals 4. So I distribute. I have negative 4p here. 8p minus 4p leaves me with 4p minus 12. Add 12 to both sides. 4p equals 16, then p must be 4. Okay. Oh, this one looks lovely. We're going to have to remember that 216 is equal to 6 to the 3rd. So this guy, with a fraction, we're going to rewrite it as 6 to the negative 1 raised to the 3x plus 2 times 6 to the 3rd raised to the 3x equals 6 to the negative 3. So now I've got negative 1 times 3x plus 2 plus 3 times 3x equals negative 3. That's negative 3x minus 2 plus 9x equals negative 3. 9x minus 3x is 6x minus 2 equals negative 3. Add the 2. Divide by 6. And that's what I'm going to have here. Now for this guy, we're going to have to rewrite it in similar fashion. That plus that equals 6 to the negative 3, which means that negative 2x plus negative x equals negative 3. That must mean that x equals 1. Now, I'm going to have to take the top. Well, I guess we're going to have to look at it this way. First of all, that 3 to the 4th raised to the 3n plus 2 and 3 to the 5th, 3 to the 5th raised to the negative n equals 3 to the 4th. That must mean that this exponent of 3 minus this exponent of 3 equals that exponent of 3. All right, so when I combine my like terms, I get 12n plus 8. Negative 5 times negative n means plus 5n equals 4. 12 plus 5 is 17n plus 8. And there we go. It's not pretty, but it should work. All right, rewrite from exponential to logarithmic. So we're going to say log base 2, the exponent goes over there. Log base a, the exponent goes over there. Log base 4, the exponent goes over there. And so that is everything written from exponential to logarithmic. And then we go back the other way. So we can say 5 to the 11 is w. We can say 4 to the y is 14. We can say x to the 3 is 12. I believe that is everything.